Yeah, welcome everybody. Welcome to today's lecture in modern database concepts. We are in the chapter of NoSQL databases. Please write in the chat hello, so that I know that you can hear me. I will just open the chat. Okay. Hello, hello, howdy, hello, hello, hello. Nice. Okay. Yeah, in NoSQL databases, we took a look at some properties last time. So NoSQL stands for not only SQL. Typical properties are NoSQL databases are distributed databases. For example, in a Redis key value store, we distribute the key value pairs over the nodes in a cluster. If we store 1 million key value pairs in a Redis database, then 100,000 are stored on that machine, 100,000 on this one, if you have 10 machines, and so on. And this is very typical in NoSQL databases because many NoSQL databases are so-called aggregate-oriented databases, aggregate store. Aggregate has nothing to do with an aggregation function, or the word aggregation means, aggregate means the whole thing, and we store the whole thing together. Last time we had sets in Redis. The key in a Redis database is the video ID, and the value is the set of all people who watched that video. This can be a set of 100 million elements or so. And this whole thing, this aggregate, is stored together because it's good that we have all the user IDs that watched this video together. If it would be distributed, if this would be distributed, then it would be very expensive to combine it, because you want to ask questions like, how many views does this video have? It is just stored on one machine, this information. They don't have to communicate with each other. It's good to distribute it row-wise or key value pair-wise. In HBase, we have rows in tables, and the row ID is the unique identifier, and we have range partitioning across the row IDs. Distributed storage also allows distributed computing. So the use case that I said was we have multiple machines. Let's say we have a cluster that consists of, let's make it simpler, 3 machines. Distribution also has the benefit of load balancing. Redis is made for a very high throughput, so you can ask thousands and millions of queries every second. That's not a problem in a Redis database. And if it gets too slow, simply add more machines. Let's say we add 3 more machines. Then each machine has about half the load it had before, because one query only accesses this machine because it's interested in the key K123, which is stored here. And yeah, this is good for load balancing, but it is also good for distributed computing. When you have a very complex query, let's say find the most prominent video of all or something, this is not what Redis is made for, but it is possible. But here, all machines have to help working on the answer, and they can do it in parallel. So that's the difference between distributed storage, just storing the data in a distributed way, and distributed computing. every machine helps answering complex queries. Another property I show to you, high scalability. Simply add more machines and it gets faster, the whole system. Most NoSQL databases are open source and very cost effective thus. And schema flexibility is a typical property. You don't have to say create table and then these columns and so on. In Redis you're kind of restricted what you can model, but in MongoDB we will see today we can store arbitrary structured JSON documents. So they are supporting semi-structured and unstructured data, and the data model is a non-relational one, for example JSON or graphs. We took a look on the 4 categories, key value stores. We saw Redis. We can use set and get to simply add simple key value pairs. The value can also be a list. So the key is still a key and the value is now a list of multiple elements. They are ordered. They have a first element, second element. You can push something on the end and push something on the beginning. Remove something from the end and in the middle and so on. So the L in L push stands for adding something on the left. We saw sets and hashes as other data types, but that's basically it. Redis is not a full alternative to a relational database. You can do very limited things, but very fast. HBase has tables. We create tables. Here's a table website with 2 column families. In each column family, we can store arbitrary columns. For example, we stored the website with a row ID othr.de, and other websites could have other columns in the info column family, but here we store the title and the language. And then in the links column family, we simply use link names, link URLs of other websites that this website links to as column names. HBase uses range partitioning, and that I want to talk about today, because the row ID, you know IDs, you know primary key, auto increment, numbers, for just identifying something in a relational database. My table has a column ID and my first customer has customer number 1, my second customer has customer number 2, and so on. This is the primary key, and on the primary key there is an index. So this is typical for relational database systems. And when you now log in, and you are logged in as user number 2, then there are multiple queries that have in the where clause where ID is 2, because I am user number 2, and a lot of queries use where ID is 2. And this is very effective, efficient, because there's an index. That's how relational database systems work. In HBase we have to think a bit different of how to design the row ID. Here we cannot speak of designing something. It is an integer, 1, 2, 3, 4, 5. But let's take a look at this example here. Here we say the row ID, first of all, is the word user, then the user ID, then a slash, and then a timestamp. So that's not written somewhere that we have to do it like that. That's a design. Somebody, a smart person, okay, this was me, I'm not a some database designer has to say, I design the row ID like this. And why like this and not like this? like that. This is an alternative way. Let's stop this poll. We will do it later. Yeah, I ask to you, what do you think? Why did I choose this design? User, then the user ID, then slash, and then a timestamp. And here you see what we store. Some user, the user number 5, did something on that timestamp. What is timestamp to time? We can convert it, epoch converter. I paste the timestamp here and we see, it is the 27th of April, 8 o'clock in the morning and something. So at the 27th of April this year, user 5 did something. What did he do? He searched, and in the search properties of a search engine, he says, or she says, image. The type should be an image. Then the query term is, I want to search images about cats, and not arbitrary ones, but size. And the user has this IP address. And then some minutes or seconds later, another user comments in a social network or whatever, comments on a post with that ID, the text okay. So we can store arbitrary things in this table here. Okay, but we will talk about the row ID here. Why did I choose user slash timestamp? So which of the following queries works well for this row ID design? Please take a look on the answers. Who logged in at the 7th of April 2021? Find all comments of post 923.921. The 10 most recent activities by user 5. For each IP, count the total number of activities. So basically all questions can be answered, but some are very expensive, some are very cheap, some are expensive but would be cheap if we would choose another row ID design. But for this row ID design, user ID slash timestamp, which kind of query? And remember, HBase uses range partitioning. Which kind of query is cheap for this row ID design? We have 35 visitors, not visitors, watchers currently, and I wait until 25 to 30 have answered this question. Come on, go to frage.de, Frage with 2a. And please show me the answer. One more, please. Okay. Yellow is correct. Most of you answered it correctly. Let's take a look on this other answer that 20% of the people have given here. Who logged in at 27th April? Okay, you see this is something that has to do with the timestamp, but if you would want to allow fast answering this query, who logged in on the 27th of April, the timestamp has to be before the user ID, because we allow not only equality predicates on the row ID. We can say, give me the row where row ID is user5/1619. Nobody asks this kind of query, because from where does this row ID be known? And but we allow greater or equal, smaller or equal, and with that we allow between. So basically this is a between predicate, and between in strings is basically a prefix search. So we can ask for user5/ and then I simply use the SQL syntax for like. So give me everything that starts with user5. User5/ finds every activities that user5 did, and the 10 most recent ones. Okay, we have to search it. We use a scan in a specific direction. So we simply follow the order that it is stored in the HBase database. So the actual query, or we cannot call it query anymore. In Redis, it still wasn't a query. In Redis, we had simply method calls. Redis.get, Redis.lpush, Redis.something. So we call a method and Redis does something. This is not a query. And here's also not a query. Basically, this is a Java program. I scan, and scan takes a start row ID and a stop row ID. So basically this is a range-based scan, a between scan. We start at user5/ and we stop before the row ID user6/. And everything in between is something that has to do with the user5. And I set the property set reversed true. So I begin with the last row ID that is before user6. So I begin with the row ID that has the highest timestamp, and then the second highest timestamp, and I stop after I read 10 rows. So this way I can write a Java program that tells the HBase database, hey, please give me the rows with row ID user5 and between user5 and user6. So everything that starts with user5/, and give it to me in a reverse order. So I see the most current ones, the most recent ones, those with the 10 highest timestamps. And this is possible and very efficient because I choose the row ID like that. If the row ID would be something like this, it would not be so efficient. Basically here I have the very same kind of data. I say, somebody performed a search operation on my portal. This is the timestamp and this is the user. And now the same columns again. Basically here's one column less because the action is now part of the row ID. This way it is not possible anymore to say, give me the 10 recent activities of user5. Not possible. But now I can ask things like, give me the answer please. Search timestamp user5, comment timestamp user8. Which of the following queries works well now? So the same answers again. Which ones are now cheaply supported? Which are now efficient? again, as soon as 25 people have answered, I will show you the solution. Now you're very fast. Let's wait some more seconds. Wow, 29 answers. Okay, this looks as everybody has answered now. More than everybody. We have 36. Okay. Activity, timestamp, user who logged in at the 27th of April. Yeah, I search for login / and then I generate a timestamp 27th of April. Again, I can use this epoch converter here. Of course, in programming languages we have functions built in. So 27th of April. I go to the midnight, and then this is the timestamp that is my start row. So I search for login / this is my start row, and my stop row is login / I can use the other slash here for the beginning. Yeah, it depends on if it's included or not. So basically, let's say 1 second before midnight. If it's included, I'm not sure whether the stop row is included or not. If not, then simply use the next day. So basically, this is this would be then the stop row 1 second later. Yeah, and the user ID is part of the row ID, but that doesn't matter. So it is like when you have a multi-dimensional index on or in a relational database system. So you say create index on a table blah blah blah, and the columns ABC. This index helps you when you say where A is this, B is that, and C is foo, but it also helps you when you only use parts of these columns from the left to the right. So an index is also used when you use where A is this and B is that and C I'm not interested in. And that's what we do here. We want that the login is at that the activity is login, and then the timestamp is between these two values here, and the rest is not is simply everything. So we again do a scan. We begin at login / this timestamp, and we end at login / this timestamp, and this is the same. Yes. Okay, that's it about HBase. Please write all your questions you have about HBase in the chat, please. What I wanted to tell you with this example is that when you use HBase or other NoSQL databases which are similar, or Redis, that you have to design your database in a way you want to use it later. This sounds a bit weird because in relational database systems we think in tables, and they are so independent of how you later query the database. I store customers here in this table, orders here, ratings there, products there, and then after in the end you can write group by queries, join the tables, and so on. This is here very limited. You have a very efficient and powerful and fast way to access the data, but only when you store it in a way that these operations are well supported. If you store your data like this and you want to ask, give me the 10 recent activities, this is extremely expensive. You have to scan over all data in your tables. If you have your data like that and you want who logged in at the 27th of April, this is not possible in a cheap way. So you have to think about the queries that you want to ask the database later. Same for Redis. I want to ask how many people watched this video. Okay, I could use a number to increment. Okay, but then every watch should count only once. Okay, then I use a set to model that. So you have to, in the beginning, first think of how do I model it. And one step before that is which database should I use? Should I use Redis or another key value store or another NoSQL database? And often there's the beginning in just using a relational database, and then you come to the limits. Oh, this operation is so expensive, I have to find a good solution, and then you build a database that supports you in that special kind of query. Okay, no question. Here's one question. For what kind of queries the database has to be sorted? For that kind of queries, the database has to be sorted, of course. HBase stores the data in sorted by the row ID. So, and I don't know so many other databases that do that. MongoDB has an index on the ID, so it's also possible to access on the IDs in a sorted way. But yes, storing the data sorted, or at least having an B-tree index on the row IDs, makes it possible to do those queries. It does not necessarily mean that there must be a clustered index, so that it is actually sorted. This is very expensive when you want to insert something in the middle, then you have to shift everything to the right. It is sufficient to have an efficient access in a sorted way, an efficient sorted access. And this is possible via a B+ tree. So the data has to be split using range partitioning or over the nodes in the cluster, but within the nodes an index structure is sufficient. It does not need to have to be really sorted there. Okay, MongoDB. MongoDB is a document database, and we already looked a lot on JSON documents. And the idea of MongoDB is simply putting a JSON document in a so-called collection. So MongoDB has as its data model, so this is MongoDB. This is MongoDB, and MongoDB has multiple databases. Or let's say the whole wall is MongoDB, and this is database 1, and this is database X and something. So you can have multiple databases. That's also possible in Redis, for example. They have simply numbers. Database 1, database 0. And within a MongoDB database, you have so-called collection. Collection A, collection B. Here you can have collection C, and again a collection B. So a collection basically is like a table in a relational database. And yeah, you can now insert JSON documents in your collections. So I open a MongoDB shell, Mongo, and I can ask with the command db in which database am I currently connected. Show DBs shows me that I have many databases, and here's a people. Here's a people database, a test database, hello 5 and something. Use social network like here. From other databases you would now expect that here's an error now. There is no social network database, blah blah blah, not found. In MongoDB there is no not found error. If something is not there, then we simply continue as if it would be there. And if we need to have it, for example, when we insert something, I insert a person in a people collection. db.people means I work on the collection people, but there is no collection. Show collections. Here's no collection because this database is not there. It is still not there, but DB, I'm connected to it, even if it's not there. If something is not there, it works anyway. Now I insert something. Now closing bracket is missing. Insert. Here's the opening bracket. Then comes my JSON document, and then the closing bracket. One important fact about MongoDB is that each document needs to have a field _ID. I did not set a field with a field name _ID. I used the fields name and hobbies. Hobbies is an array, name is a string. So if I insert a document that doesn't have an ID, you see it here, MongoDB will automatically generate a unique user, not a user ID, an object ID. So db.people.find shows me this new document and the ID is now inserted. If I insert another document, let's say db.people.insert, and now I set the ID to 5 and name is Paul. Let's use Paula. Then MongoDB does not automatically create the ID because I specified it. And when I want to insert another document with the same ID, then of course duplicate key error. So the ID must be unique. Yeah, and this is the thing that MongoDB can also use for distributing the documents across the cluster. There is not a requirement that this has to be done via the ID. You can specify another field as well. So you can also say, I want to shard my collection with a name field, so that all people whose names start with A to K are stored on this machine, from L to S on the second machine, and so on. So you can configure a custom partition key, or shard key it's called in MongoDB. But the easiest way is simply to use the ID for sharding, because it's required that every document has this field. So if you say, I want to shard my documents by the field name, it is not possible to insert a document where the field name is not present. So it is a required field then, and the ID is required anyway. So it is always a good choice for distributing. But we will not talk about distributing a lot. I just want to say to you that you can store arbitrarily structured documents in a MongoDB database by using JSON. notation. MongoDB supports simple queries and complex queries. With simple queries, I mean this find command. I just showed to you db.people.find simply finds all. But find has two optional parameters. The first one is a selection, so I can say give me only those where name is Peter. Then it checks whether the field name is present in a document and it has the value Peter. This is the case for this document here. And this is now really a query because optimization is going on here. Oh, is there an index that I can use on the name field? MongoDB supports indexes. You can create indexes on fields like you can create indexes on columns in a relational database. And then MongoDB decides whether to use the index or not to use it. And it has statistics in the background like it is done in relational databases. And if you have the choice, do I use this index or that index because I have an AND combination of multiple predicates, and there's an optimizer. So MongoDB is really an alternative to a relational database system, but you are having a completely different data model. We have here a flexible data model. You can store arbitrarily structured JSON documents. It is possible since MongoDB, I don't know the version, I think 4 or something, to give a JSON schema to a collection. So that a schema can be specified, JSON schema, and only documents that are valid with respect to that schema can be inserted. But basically you can store everything in a collection. You can mix everything, and that is a challenge for the application developer because the application needs to know which fields are there, or you have to develop the application that it works with arbitrarily structured documents. So the find command has a selection, and this selection is basically similar like the in PostgreSQL we had this operator on JSON documents that checks whether a document on the left, A is 5, B is 10, contains another document. So A is 5, so this would match here. And in MongoDB is basically the same. You provide a field and a value and probably other fields and other values, and these must be present in the document. If yes, then it is found, otherwise it is not found. So this will not find anything. But it's also possible to give patterns here. For example, greater than Pete or something. Then you must use some operators, or not equal. Give me all people who are not called Peter. Then we find Paula. Yeah. So it supports complex queries like in SQL, but everything has to be provided in JSON format. And that's why queries look a bit ugly. And the second parameter of the find command is a projection, because here we see the whole document is found. And when I say I'm not interested in the whole document, but only in the ID, then you say ID, yes, 1. Did I close? Yes. No. I have to close the projection here. This is the projection bracket, and this is the selection. This is the projection, and now my query is finished. And then I only find the ID of the person whose name is not Peter. So basically, this is select ID from people where name is not Peter. So this would be an equivalent SQL command in a relational database to that MongoDB command. DB people find, then the name should not be equal to Peter. That's the selection, and then only give me the ID. Yeah. You can also say, give me everything but the ID. Then it only shows you the name. And if you say, give me only the name, then you see the ID is there as well, because the ID is always in the result if you don't exclude it, because the ID is so an important thing. But this is not so relevant for now. So I just want to show you how to work on a MongoDB database. We'll do this in an exercise, and yeah, find commands on a collection can be used without a predicate, then it finds everything, or with a selection, or with a selection or projection. If you only want to do a projection, then you simply use an empty array, an object here. Yeah, but projection is not so important, but it's possible here. After your find command, you can continue your query with some further steps. One is sort, and the other is limit. Limit without sort works. Then it gives you only the specified number of rows. It's also possible to say count, and it just shows you how many rows there are. So this is yeah, like a little pipeline, but it's very limited. You can, after find, you can say count, you can sort, you can limit. In the sort, you specify a sort criterion. In a JSON document, you specify a field, for example, name, and then 1 for ascending, so from A to Z, or -1 for descending. So this way it gives you first the Peter and then Paula, and ascending it would first give you Paula and then Peter. Yeah, and you can use this in a combination. Hobbies was an array. So one slide backward, we had here Peter with an hobbies array, and MongoDB evaluates selections on arrays simply as if the array would be unnested, if it would be each of the strings. So you don't need to use an in operator or something. By default, you can simply say hobbies yoga. This would match to documents that have hobbies and the value string yoga, but it would also match to documents that have hobbies as an array in which the string yoga appears. Okay, before I continue with MongoDB, I take a look in the chat because there are questions about HBase. I copy the question simply to this editor here, so that we have this question now. What is the advantage in using HBase to using an SQL table with a JSON column? Are there go-to use cases for using HBase. Seems like it provides the best performance when performing tasks by key. Yeah, in HBase, oh sorry, you don't see it. So what is the advantage by using HBase to using an SQL table with the JSON column? Because SQL with JSON also gives you schema flexibility, and you could say the same about MongoDB and a relational database now. Oh, when I press here button, something happens. I copy. So this is not your fault. So this was the query. What's the advantage? Yeah, if you want schema flexibility, you can also use SQL with the JSON column. And yeah, the best performance you have when you do tasks by key. Exactly. Okay, in NoSQL database, you have distribution. You have a distributed database across nodes in a cluster, and this is very good for big data. And if you would use this in an SQL table, this works well if you have 1 million rows or 10 million rows. But if you have columns with large text data, which are not natively supported with searching with a like predicate or using more complex search on the data, then HBase is good. So for distributed processing, big data analytics on very, very big data, which is semi-structured and unstructured. Relational databases come to their limits. They support all that as well, but they are not so good in distributing and distributed processing there. Then there was a that's the same question. Yeah, that was simply doubled. Okay, if you have questions to MongoDB, just ask them now. I continue with indexes in MongoDB because I told you that the query from before, where I search for people with the name Peter, let's see. I have here the query, people find, the name is Peter. It finds this row because name is Peter, and I can now say explain, and this explain shows me now it does a collection scan. Collection scan is basically like a table scan in relational databases. Table scan means go to the first row of the table, check whether the predicate is fulfilled or not. If yes, it's in the result. If no, then not. And then the same for the second row, then the third row. That's a table scan, also called a full table scan. In MongoDB, we call it a collection scan. And so for each document in the collection, we check whether name is equal to Peter. Yeah, so no index is used here. And if I create an index, db.people.create index on the name column in an ascending order. Okay. Before that, there was one index because by default, there's always an index on the underscore ID. And now we have two indexes. And then again, I use the find command. And now it uses the index scan, not a collection scan. Now it uses an index scan. So with that, I only want to show to you that MongoDB supports indexes. Would you rather store data with different structure in the same collection, or would you use multiple collections and join the data then? That is a very good question. That is a very, very good question. And I have to come back to the term aggregate. Aggregate database. Aggregate means the whole thing. In German we would say Gesamtheit. The whole thing we store together. And you have to design your documents in a way that you want to query it later. When you have collections which are basically independent from each other and you very rarely need to join them, then this may be a good approach to store products in this collection and ratings of the products and ratings of the product in that collection. This would be one design. And if you want to find products that have a rating better than 4.5, an average rating better than 4.5, then you have to join those. And this collection is splitted and stored on 3 nodes on the cluster, and this is splitted and has 3 nodes on the cluster, and maybe this product here has this and that rating. This sounds not so good to join things over the nodes on a cluster. Other databases support these kinds of joins by saying I set a distribution key, blah blah blah. In MongoDB, this is not how you do it. You would not store things that belong together, store in different collections. You don't want to join them afterwards. Joining is something that you have from SQL. It is possible in MongoDB to join, but see it as a feature when you as a workaround. So when not as a daily business, the join should be used exceptionally. The better approach would be have one collection products, and each product has an ID, and a product has a name, a price, and then a ratings array. And in this ratings array, you then nest all the ratings. Then you have everything together that belongs together. So you store the whole thing. You store an aggregate. If you now click on the product on a website, in the background, db.products.find with the ID, the given ID from the URL, is queried. And then in the resulting document, you see everything that you need to build the page, to find the title, the price, all information and the ratings and so on. And if you want to enable a search or a product overview, then you are not interested in the ratings, then you simply use a drop projection. That was the projection where we say I'm interested in all attributes but not in the ratings attribute. And you say in the projection ratings, this is a large array and I'm not interested in it, so you simply remove it from the result. That's how you do it in MongoDB. So store together what belongs together. So to answer your question, would you use multiple collections? No. One collection and store it together. And often you have the choice. Do I store for each product all ratings, or do I store for all ratings the information which product was rated? And this depends on how your queries will later look like. I showed to you a query. I click on the website and I want to see all ratings for that product. I click on a user and I want to see all ratings that are from that user. If you want these kinds of queries, then you need a ratings array in the user table. So again, like in HBase, it depends on how your queries look like. Multi-key indexes are, these are normal indexes, but each document can appear multiple times in that index when the field that you index is an array in that document. So let's start with this example. Create index on the name field. I insert a new document. The name is Bob, and now in a B tree I insert Bob and then a pointer to that document. So I quickly can search for a name. If I have an index on a field which is in my newly inserted document an array, for example, an index on the field hobbies, and I insert a document hobbies, yoga, tennis, piano, then my document is inserted as often in that tree as I have elements in that hobbies array. And this makes it possible to search something within an array, like we saw it for the index on JSON data in PostgreSQL. So I insert a document, a new person, and that person has the ID 1, and this person has hobbies, piano and yoga. So I insert in the B tree, if it's not there, a piano element and a yoga element, and point both to the newly inserted document. And when I later ask the question, give me all documents, give me all people that have hobby piano, then I find those which have it in the array. And the last thing I want to present about MongoDB is a way to query the database with more complex queries. The queries that we had, here this find command, is very limited. You can make a selection, only those where the JSON document follows the following structure and has the following field values. You can have a projection. I'm not interested in all fields, but only in those and not in those. You can sort the result, limit, and paging, so skip and offset for the limit is also possible, but that's it. More complex queries, for example, group by and so on, are possible with an aggregation pipeline. And I want to show you this aggregation pipeline because this is a concept that we see very often later this lecture in other topics, because pipeline always means do this and then with the result do that, and then with the result of that operation do that, and with the result of that operation do that. So these are so-called steps, pipeline steps. Pipelining was invented by Henry Ford. He didn't invent the car, he invented pipelining to make a car very cost effective for everybody. And the goal, the magic was pipelining. There's one person who does this step on the car, and when he or she is finished with this, he gives the car to the next person, and this makes this step on the car, and then they give the car to the next person. So they have a pipeline of small jobs, and in the end there's every 5 minutes a new car, because it is very well parallelized. So pipelining is good to parallelize things, but pipelining also makes it possible to make arbitrary queries. The query that we saw before with the find command is also possible with aggregation pipeline, but I want to show you that the aggregation pipeline allows even more complex queries. The aggregate method takes an array of multiple steps. A step has a name, there's a match step, a project step, sort, limit, group, unnest, out. So there are multiple steps, and you can combine them in any order. For example, the input is the whole collection people. The first step is a match step, so basically a selection. And all documents that survive this match step. Match can also be called a 1, 2, 0 or 1 step. 1, 2, 0 or 1. So one document comes in that step, and either it survives because it fulfills the predicate or not. So this is a 1, 2, 0 or 1 step. The next step is a sort step. So here nothing is removed from the collection, from the result. It just changes the order. And then a limit step limits the result to only 10 rows. And a project step is a 1-to-1 step. So if you have 10 documents because of the limit 10 before that project step, then you have 10 documents after that project step as well. And the nice thing on aggregation pipeline is that you can work step for step. So let's take a look. I have here a collection. Let's take the example from another exercise. We had an exercise with Pokemon. So here, and I simply insert a JSON document here. So db.monsters.insert, and I insert that monster here. Oh, db.monsters.insert, opening bracket, closing bracket. So now I inserted it, and I use a second one. There's also the possibility to import the whole thing, but I don't want to use it now. So monsters.count, now I have 2 documents, and I can use a pipeline now. So I don't want to find all monsters, but only those which have speed larger than 50 or something. So the match step, which has base.speed, we use the dot notation for going into subdocuments, and this should be greater than 50. This is the closing bracket from there. This is the closing bracket for there. This is the closing array of the aggregation pipeline. and this is the box, the normal bracket here. So this is just one step that doesn't find all monsters, but only those which have speed greater than 50. And I find this one here and not the other monster, because this does not fulfill this predicate. And then I can continue. Okay, based on this result, I want to project, and I only want to know the field name. Yes. Okay, I missed a curly bracket here. So project step name, yes. Okay, and then we see the ID and the name. You can also say .pretty. It's a feature of this shell to see it in the pretty format. Okay, and with that we can then continue and add more and more steps. And the aggregation pipeline allows further steps like unwinding an array. So we have this hobbies array, and unwind means if a person has 5 hobbies in that hobbies array, it appears now 5 times. So Peter appears with each hobby once. So hobbies is now, after this step, not an array anymore, but a simple string anymore. So there's one Peter with yoga, one Peter with piano, and so on. So this is the unwind step. And for a group step, like in SQL, we can say by what do we want to group? I want to group by hobbies. And which aggregation function do I want to use? So if I would say I group by hobbies, and then I use sum, I can then count how many people do have the hobby yoga, how many people do have the hobby piano, and so on. But I don't use the sum aggregation function here. I use push. Push is an aggregation function that builds an array based on the elements of the group. So I push the names in an array. So the result of this query is a collection of documents with the ID being a hobby. ID is that what we find in hobbies after we unwind the array. And names is a new field that we introduce, and it has an array of all names that have this hobbies value in their hobbies array. So basically with this query we reverse the nesting. In our original document we had name Peter and an hobby array. Peter has the following 5 hobbies, colon, blah, 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 blah. And now I reverse the nesting. The hobby yoga is used by the following persons, Peter and Jane. Yeah, this should just show that it is possible to make complex and advanced queries with the aggregation pipeline. Aggregation pipeline was added in MongoDB not in the very beginning, but very soon. It is supporting distributed computing, and it supports usage of the indexes, and you can store the result somewhere, or you can simply look at the result. And there is another way to make more complex queries using MapReduced. This is not recommended anymore, but nevertheless, I will give you in a few weeks an exercise on MongoDB where you use MapReduce then, just for practicing the concept of MapReduce, not as a recommendation, please use MapReduce in MongoDB. MapReduce was necessary before there was the aggregation pipeline. Now you do all complex queries with the aggregation pipeline. Okay, do you have questions? Please write them in the chat. Questions about MongoDB. I have a question for you, so please answer this on frage.de. What do you think? What would happen when you write hobbies instead of $hobbies? I don't expect from you that you need to know all details about the aggregation pipeline. You should know that it exists, that it is possible to do steps. It's not really necessary that you learn all the why is there $1 and there's no dollar in something, but think a bit. What do you think would happen when I write here the ID is hobbies and not $hobbies within the group? Would it make no difference? Would it be would there not be 3 groups, 3 document, but only 1 group with the ID not yoga and piano but hobbies? 1 group for each person document, so 1 group for Peter, 1 for Jane, or would it give you an error? Can you push the whole document in your current example, not just a single field? Yes. So here I have only the person Peter. You mean not just the word Peter? I think this is possible with root. No. Somehow it is possible. I have to Google for that. $root. Yeah. So when we write in that names array, I push $root, then hobby yoga has the whole document now within the array. Yes, that's possible. So that was the question, can you push the whole document and not just a single field value? Okay, let's come to this question here now. We see dollars on the left of a colon, and this always means a MongoDB keyword, a built-in operation. So in this case here, the name of a step, a match step, a sort step, a limit step, a project step. In another example, I had $GT greater than, or $NE not equal. So on the left of the colon, the dollar is some keyword from MongoDB. On the right of the colon, like here, it means attribute dereference. And this is a concept which means I don't say, let's take this here, the ID is ABC or 1, 2, 3. The ID should be what's currently in the field hobbies. So I look in hobbies, what's there, yoga. So the ID should be yoga. And that's why when I would not write, so this is the query. If I would not write $hobbies, but only hobbies, then the result would be an ID with the key hobby. Here, an ID is hobbies, and then, okay, push is pushing something into a list. Lists do not have duplicates, so it would be there twice. So it would be equivalent to say in SQL, group by hobbies, that's what we want, but group by the value hobbies. That would be the equivalent thing here. So one group. Most of you already did it correct. Very good. Yeah, that's very nice. Then let's come in the last 15 minutes to the last category of NoSQL databases. And I want to talk about graphs in the next weeks as well, because graphs is a so big topic. I will show you today graph databases from NoSQL. Next week, RDF, Resource Description Framework. This is a way to model graphs, and with a language called Sparkle. And then we continue with graphs in SQL, because there's a possibility to make recursive queries in SQL. I think for most of you this is new. So recursion means calling itself. So basically in the from clause you call yourself again. So with X, from X. We will do this in a few weeks. So we will work with graphs a lot. And as an introduction, graph databases simply use graphs, like we know them from math, as their data model. A graph has vertices. This is a vertex, this is a vertex, this is a vertex, and edges. Edges connect to vertices. And these are graphs in math. In a database, in a graph database, we have property graphs. Property is basically like key value pairs again. So this node has an arbitrary list of properties. Name, Peter, age 25. And this node has other properties, and this node has other properties. So each node again can have arbitrary properties and values. Name, age, name, city, and so on. And so these are properties, and nodes and edges have labels. And this edge can, for example, have the label lives in, and then here name is Berlin. Peter lives in Berlin. Peter has a friend called Jane or something. So this is a label. And I said nodes also have labels. So this is having the label. I don't write label, I simply write it here. Person, city. So nodes have labels to indicate what kind of node is it. And labels for nodes in I wrote here document database. Of course, Neo4J is a graph database. This is a typo, a copy-paste error. Neo4j is a graph database. So in graph databases, labels, node labels are basically what tables are in relational databases. So we store people and cities, but everything together builds one big graph in a graph database. And then we distinguish the nodes by giving them different labels. And then we can use these labels in queries later on. So vertices have a label. Basically, this indicates the node type, the vertex type. And vertices have a set of properties. So properties don't have an order and each key is there only once. Here's an example. A node, I use the syntax that the language Cypher uses. We take a look at this language next week. This node has the label person and a set of properties. Name is Peter, city is Berlin. So it looks like JSON here, but it's very limited. You cannot have sub documents, arrays, and so on here. It's just a list of key value pairs again, a set of key value pairs again. And edges are a directed connection. So let's correct this here. Edges are directed edges. So Peter lives in Berlin. So this must be not a line, but an arrow. And Peter has a friend. Has Peter the friend Jane, or does friend have? So basically, this is an undirected edge. But all document database, all graph databases that I know do not support undirected edges. So they simply say, make the edge in an arbitrary direction. Write the friend's edge in that direction or in the other one, it doesn't matter. When you later query the data, for example, give me all friends of Peter, then use in the query the expression, the direction of the edge does not matter. I traverse the edge in both directions. If it's incoming or outgoing, does not matter. So edges are a directed connection between two nodes, and edges have a label, friend, lives in, and edges can also have properties. So since when are Peter and Jane friends? Since when does Peter live in Berlin, and so on. So here we can also have properties which describe the relationship between two nodes further. Yeah. A node and another node has an edge with the edge label friend and the properties since the 4th of May. And the graph, which results in that, can then look like that. So we have a person node, so of label person, and another node with a label person, and this person node has two properties, name and city. This person has name and city, and they are connected via an edge friend, and then this friend edge has one property, since, and that is that date. And now again the question is, do I have city nodes and then an edge, somebody lives in that node, or do I have a city property? So again, you have to decide how to model things this way or that way, and it depends on how you want to query the data. It depends on, do your cities have further properties, so the number of inhabitants and so on, and or is city just like a column in a person table? So you have again multiple things how to model things. Yeah, that's the basics of Neo4j, or basically property graphs are the base of all graph databases. This hurts a bit that I wrote document databases there, so it must of course be graph databases. So with the query languages for graph databases we will continue next week. Do you have questions about MongoDB, Neo4j, HBase, Redis, questions about NoSQL? So Neo4j is a graph database. Did you understand the data model concept of property graphs? Vertices, edges, both have a label, both have properties. Edges connect to vertices and edges are directed. The exam will not be similar to the exercises, because the exercises require a lot of Googling and programming, and in the exam or oral exam or written exam I will ask for the concepts behind that. So the exercises are there to understand the concepts, and in the exam I will if it is an oral exam, we simply talk about the topics. we simply talk about modern database concepts. And in the written exam, I will give you further instructions if it will be a written exam, but I hope that we will do more oral exams. But this is not determined yet. What data types can values of properties contain? That depends on the graph database. In Neo4j, I'm not sure. Actually, I'm not sure in any graph database. I always use strings and integers. Can simply Google Neo4j property types. So integer, float, string, boolean, point, date, time, local time, date time, local date time, and duration. So scalar values. So point looks like longitude, latitude, coordinates, but everything else is just one literal atomic value. No complex types, simple types. yeah, I'm not sure about composite types, lists and maps, nodes, relationship, path. This, oh, they have a new logo. I need a new t-shirt. Oh, I don't have my Neo4J t-shirt today. Yeah. Will there be an exercise on Friday? No, there are holidays on Thursday and Friday, so the next lecture will be next Tuesday and the next exercise will be after that Tuesday, the Friday. But I will upload an exercise sheet today or tomorrow, and then you have 10 days time for solving that. Okay, then thank you very much for attending today's lecture, and see you next week. Have a nice time. Goodbye.